down the shed.
Hi, welcome to Down the Shed, me Jason. In this video we shall be making a cheap LED torch. So this is your typical cheap Chinese trash that I love to make. So we've got a little plastic case. Probably one of the better packed ones, since it comes in its own little case. We've got a little circuit board which also has an area for practice, not that there's any reason for that really. It does have tracks going to it, so not sure what that's all about. But yeah, there's really no need to be messing around with that side of the board. You could literally cut that off, I guess. But anyway, let's just crack on and put this little puppy together. So here we have all the parts laid out. We've got a transistor, a switch, the switch cap, battery terminals, jumbo LED. I'm not sure what they are. Is that a capacitor or a transistor, or can somebody let me know what one of those is? I've seen one before in a clock kit, but I really have no idea. And some resistors, so let's find out what the value is. So we have my trusty component tester, bang good, 12 quid, brilliant little kit. Can't rate this one high enough. So we'll switch her on, put her into test. We have a resistor between pins 1 and 3, which is 56.2. So I'm guessing that's what, 47 ohm. I'm guessing, even though it's 56, they're never always cock on. Let's try another one.
I don't think anyone sells them, and it's not really something that we're familiar with. But I'm going to try making one anyway. Now, of course, the idea is you make this sort of around the outside there, so you can put your stuff in the middle. Now, the problem is, I think I made this too chunky, to be honest. It didn't really fit in it very well. It seems
so you could just put the colour bands into a resistor calculator once I get this in.
The top a little bit as it was cooking, and the whole thing emerged much too early. It kind of jumped out a lot sooner.
Right, she's not in nicely. Let's get her in a bit better.
Now, there's no way in hell I'm going to try eating this thing, not suicidally. You can see all the eggs that are coming out of the top there. So obviously it's hardly cooked at all.
So we've got a 46, bang on. So they're 47 ohm resistors.
Put it back in the other way if you want to cook it a little
and we'll put this in and just see what happens.
As you can see here, when I cut into it,
be interesting.
It's very raw inside. I don't think I'd want to eat that unless I was trying to commit suicide. So let's try something else now. This one.
So it's showing up as a resistor, and it's a 6 ohm.
Gonna cook a
0.6 ohm.
Well, kind of a burger.
So that's probably like a 1.
Burger. Just plop it in there. You can't have it the full length of the thing. You've got to make it about halfway up so that it's got a bit of room to expand, a bit of room for the fat to jump around in, and then put a wooden skewer in it as well, so you can get it out at the end, of course, because it might get stuck to the sides.
Surprisingly, absolutely no markings on there to suggest what it is. So that's a 0.6 ohm resistor.
You know what? That actually does.
Right, let's see if this LED lights up. Jumbo LED lights up.
Taste at the moment, but looking at it, that looks like a burger kind of should do. Nicely charred on the outside there, cutting into it, cooked all the way through, no red.
So there we go, it's just a white jumbo LED. However, we won't be using that.
Don't mind if I do.
Because I going to swap that out.
But after using one myself, I realised that it can be a bit of fun. You can experiment with your food and try and mix different things.
For a 3mm UV, and I do need to buy some 5mm UV. And after seeing the size of that, I want some flipping. What's that? 10mm? 15mm? So we've just heard an episode of Techmoan in the background. So Matt now has his millionth subscriber. So I will link to Techmoan in the video. Right, so this is going to be really easy. I need my right. Can't read lens anyway. Right, so turntable for whatever reason isn't spinning, so we'll need to. That says 47 UH and it's a massive hole, so I'm guessing that this is going to go in there like that. That's the LED.
this is a simple mechanism. We've got a rubber
There's the transistor, one of the resistors. So you get 4 resistors. So they've given you some spare resistors to play with.
Now, depending upon what speed is selected,
So we'll pop R1 in.
moves up or down the spindle so that it makes contact with the section with the appropriate.
We'll pop the transistor in. Bearing in mind, this is polarity dependent. Well, not polarity, yeah, kinda. Base collector and emitter. So it can only go in one way, otherwise you get 2 of the pins the wrong way round. So there is like a semicircle shape on the board, flat edge and a conical side.
Snag any of these wires that go from the base up to the top section.
So you get the shape of the transistor to match the shape of the board.
Checking that's connected up, and then following those wires around to the circuit board. And they all seem to be attached.
Right, well, apart from that big one, we can't put a lot else in my circuit holder.
And also following any wires that go down off that, see where those end up, and those all seem to be attached as well. There's a couple of black wires that lead off the bottom of here that go into the speaker that's inside the lid. The blue and red wires on the right are the ones coming from the battery compartment. We know that's fine. We're getting power through
those a little
the
bit
mains
more of a
wires on the
bend.
left leading into the transformer. That in turn is connected to the
Slot that
voltage
in.
selector, which you can access from the other side by twisting a coin in that slot. So everything in here looks fine. So I move the arm again.
Transistor's going to hold in there nicely.
Any more, and this time I could hear the motor running. And sure enough, when I reached onto
We'll
the other
just
side,
pin
I
these
could
2
feel
in.
it spinning around on my finger. Yeah, it's all working fine now.
Turn the iron on.
Absolutely nothing, and it's working. So I had another good look at the circuit board, just away from that. Don't just try and force it upwards. Now, cleaning an inside that no one sees might seem pointless, but during that cleaning process, I noticed the bolt on this hinge was loose. So if I hadn't cleaned it, that's something I wouldn't have spotted.
Right, so wipe your iron, tin your iron.
Fitting the right hand side first under that bracket, and then also making sure all the springs that isolate the top from the base are located properly before putting the 2 screws back in. Now, before I put it on, I'll just clean this metal platter as well. It doesn't look dirty, but I just want to make sure it gets good contact with that rubber wheel, so I cleaned it with a bit of isopropyl alcohol. And that spins nice and smoothly, so just a matter of checking all 3 speeds are operating as they should, and they are. Although that's not really down to
those soldered in.
I think this thing just needed a bit of a shake to get going again. I'll clean this off though, it looks a little bit mucky. I like the way this has got a silver bit in the middle, just to make it look a little bit more upmarky when it's on the machine. Now, I recently bought a new scale for measuring the stylus tracking forces. My last one only went up to 5 grams. This one can weigh up to 100. This 20-gram weight shows that it's pretty accurate, at least up to 20. So, measuring the tracking force on this stylus shows that it's 5.9 grams, which is quite considerable, but also within tolerances. The specs for this cartridge show an acceptable range of 4 to 6 grams. So it's in there, but it's right at the top.
Stab the excess blue tack off.
Quite a few people will be concerned that a high tracking weight like that would risk damaging a priceless 50-year-old historical artifact.
So that's the transistor, the resistor, and what I think is another big fat resistor all mounted.
These records would have been played in a child's bedroom on
we'll put the switch on. I'm going to have to get rid of this.
Records were just the way you bought music. They weren't treated like a priceless object to be collected and never played. And second,
I have to bring Holly over.
Interesting, isn't really valuable. There are still loads of them around, and they regularly sell on eBay for just a few pounds. However, before I play it, I just want to test this turntable using that power lead for the first time and check whether or not it's working properly. And to do that, I'll play something familiar.
Well, the switch is a bit of a weird one. So, okay, more cheap Chinese shit. The switch doesn't fit the board. Is this typical? Yes, it is. So I'm going to pause while I figure this out.
Initially, I thought that was electrical interference, but it turns out it's actually a vibration that's coming
There we go.
from the motor and then being transmitted through the surface all the way around the pickup arm and to the pickup itself. In an attempt to isolate those vibrations in this machine, the motor was...
I'll just try and show you. If I get in view, we've got 6 pins on the 6 pins on the switch, and there's the pins on the board, but they don't actually match at all. Okay, so we're on the bigclive now, going on about power indicators, LEDs, neons, etc. That's the LED now into the board. You can see I've soldered it in and I've twisted it over so it kind of fits in there like that. So I'm still working on this switch problem. Okay, so I've bent the lead on the minus terminal. I think you can just about see it there. Let's try and get a better view. And I'm going to pin this to the board and solder it in.
We're not going to actually give them 10 milliamps. This will make it more visible. So they're both lit, but it might not actually look like both lit. One of them looks so dim, and it really is visually dim because although the same current is passing through it,
so I'm just going to pin that like that and solder that in.
Just an indicator LED. And the same happens.
So there are actually 4 tabs there for the minus,
gallium
but
phosphide.
I've already figured it onto that one, so
and this is a gallium nitride LED.
let's get you in view anyway.
And the comparison is even worse with the gallium nitride because gallium nitride is so efficient. This one is a blazing bluey green, and this one's a soft apple green but very, very dim. And you'd think then that you want to use the brighter LEDs, but unfortunately, in the case of the gallium nitride, these ones are very easily damaged by the reverse voltage, so you're going to have to use gallium phosphide or preferably just the traditional red gallium arsenide. But we'll use the brighter one of the red ones. So let's get a resistor. And it doesn't matter which way around this goes because even though it is polarity conscious, because it's polarity sensitive, it doesn't really matter because ultimately it's going to see both sides of the waveform. So let's splat some solder on this.
Right, so that's the negative in.
Grip it by something that's not going to be thermally conductive so I don't burn my fingers. So any random lead, and we'll solder that onto there.
Wow, that was quite a snip. So that should fit in there, something like that. And then of course, once we've got the other terminal on, the battery will slide in something like that. Might push that down a touch.
And I shall wet both these leads with solder. And then
bend this down a bit. There we go. So let's get the positive on.
A bit of a rough and ready joint, but that's fine.
Again, I think we're going to have to do the same. Slot that in.
So this LED will be passing 1 milliamp.
So I don't think the switch
and it will flicker quite strongly.
is using all of its legs. I think we can cut some of the legs off. So we'll pop this in.
And that resistor will be dissipating it will be dissipating its full power because ultimately this LED is only lighting one direction, but it's still when it's reverse voltage.
Pop some solder on there.
It will be lighting in the other direction. It will be passing current. Should see
just using up an old piece here. Seems it is cheap Chinese rubber.
If you're using a gallium nitride LED, then you'd have to provide protection for the reverse voltage. And the way you could do that is simply by adding a diode, an ordinary diode, reverse across that. So it flips that reverse voltage. You could even add 2 LEDs.
I'm going to use my old snips on this one because I don't want to ruin my good ones.
So the next thing we can improve efficiency is by making this actually half wave. So if we then have that resistor.
So that's the
this time we can
negative and positive terminals in, how I believe they're going to fit. I've got a bunch of these kits, so if I screw this one up, I will be selling some, but if I screw this one up, I've got another one we can learn from. So now I think that the switch is using only 2 pins, and that is literally just going to be an on and off, so it doesn't really matter. Use it all once again. So we just snip one side of these legs off.
We can use a lower value resistor, so we'll probably use
like so.
20k resistor.
So we've now got one set of legs.
So I shall just solder that up right now, and then we'll try it out and see how it looks.
But that ain't going to work. Not unless we do that. So the set you snipped off, you want to be using the opposite set to bend this across.
Because one of the other experiments involves a 1k resistor, and that would be quite visually bright from the LED perspective, and the resistor would emit smoke immediately.
So let's pin that down.
Much as you want to do that. You know, at the end of the video, I will put an LED right across the mains, just to show you what happens if you do it. I warn you in advance, though, it's not usually terribly exciting, but then famous last words, it might actually turn out exciting in this instance. Now I have to observe which polarity the LED is, because if I get the polarity wrong here, the LED won't light at all. The LED, that's the positive lead. I think that's a positive lead. We'll find out when we do this. So let's solder the diode in there.
Short bit of flux, jump out the iron. Not the iron, jump out the solder. So that should work now. They've obviously given you a few extra parts just to, or resistors, just to play with the board. I don't know why. And the spare terminal section of the board does have tracks going to it, so it could alter the overall effect. So let's just give this a quick burst here, and there we go. Oh, sugar.
So there's a better contrast, and
Turn
this
that
should
off.
be running the LED at twice the current, but it'll still be lighting half wave. So it's brighter now, but it is still visibly flickering because it is only lit on half the waveform. But that has reduced the dissipation across that resistor. Now you'd think at this point in time that you could then, because that you've got a diode in series, you could then use the gallium nitride LED because it's got
And there we have it.
protection. But in
Off,
reality,
on.
these diodes,
So quite simply,
reverse current leak through, and
I'd
you
go
still
on.
need a diode across
Well,
the
actually I
nitride
wouldn't,
LED
because
to
the
get
legs of
that
the
against
LED, I'd stick with that outer terminal for the minus.
variation in the circuit.
Same with the
The
switch
next
for the
variation in
plus,
circuit is to
so
use
just bend and snip them into size. One resistor, one transistor, the big funny resistor, an LED, a switch, and job's a good one. So let's
used 120 key there.
see if we can get it in this case somehow. It's going to rattle around
You'd have to actually,
like the proverbial at a wedding.
You'd have to calculate it, and I wouldn't even recommend using these values on 240 volts. I'd suggest using a slightly higher value just to reduce the dissipation. So actually, let's move that along a bit. Let's go back to 220k. 220k, but this time I'm going to actually use a bridge rectifier. So the classic bridge rectifier based on 4 diodes, and all the diodes point towards the positive terminal. So let's make this one the positive and this the negative, so the diodes always point towards the positive terminal. And a bridge rectifier is basically like a sort of like a series of
Right, if I bend these up slightly.
So all the diodes pointing away from the negative towards positive, and I'm going to put the LED.
The beauty of
across
trial
the
and error.
positive, like that, to the negative.
That's too high
And
now.
what this means is that when
Positive's
the
okay, the
current's
negative
flowing
just wants
in
adjustment.
this direction, it's going to go through this diode. It's going to
So
be
I'll
blocked by
probably
this, so it's
double
going to go
side
through
tape
the
this
LED,
in or something.
then through this diode
Bearing in
to
mind
the
that
other leg. And when the
the
polarity is reversed,
3mm
it'll
LED
then go through this
is
diode,
absolutely
through the
tiny
LED,
in
and through that
tiny,
diode, and of course the
tiny in
current's
comparison
going
to
the
this.
resistor. So this time, because it's
One moment, my car alarm is going off. Okay, car alarm sorted. I've left the windows open slightly because it's so hot. Basically the breeze has blown through the window and set off my ultrasonics. So this seems really big for either of these two holes. Now
That's starting to get
sort of goes in, but
on a panel. But again, I would choose either a higher value resistor or a couple of resistors in series to spread the voltage and also lower the dissipation.
I think it goes in that one
Now, if you
actually.
really want to go for high output though, then we have to come to the capacitive dropper. And I mean, this can be quite a simple circuit because it is just an indicator. So for the capacitive dropper, we're going to use the bridge rectifier again, but this time we're going to put.
So I think the supplied LED is
the-
just
a
way too
capacitor
big anyway.
Series, then a resistor.
Either
And
that
this
or you'd
time
have to
the
modify
resistor's
your
gonna have a
case
low
to make
value.
it
It's only
fit
gonna be
better.
1,000 ohms, so that's going to be 1,000 ohms.
That really doesn't want to go in
The capacitor is just going to be
either end,
basic.
and I'd have thought that, there we go, that would be the way it would
higher value.
it would
It's
fit
just
in.
not super
So
intensity
I've now got a super jumbo
If I could
LED
get
which
next to
doesn't
the
run
capacitor,
super
or
jumbo
in this
lighting.
case, I'm just going to use a generic 400 volt one. The
I
extra
had
is
super
advantages
jumbo, there it is.
designed for use in
I was going
those
to say I had a
applications.
super
It
jumbo
is
LED.
a safer capacitor to use, but these ones seem to be pretty reliable.
But yeah, that ain't going to fit in there either way, so it's either designed probably just to
it's basically
poke out the ends, like so. But that looks pretty crap. So don't know where to put this one. Put it with my 5s for now. It's like a 20mm LED or something.
So let's do that.
in with the 5s for now. So let's see what happens when we put all this back together. I might have to make some sort of... Oh, I know what we could do. Oh, we could really posh this up.
Purely to limit inrush current, because when you first connect this capacitor, depending on when you connect it to the mains, will...
So that's the torch as we have it at the moment.
And it could suddenly charge the capacitor up.
But as you can see,
this circuit works,
it's a bloody great hole.
each halfway of the mains, a small portion of
So my next thought
between the plates
is,
of the capacitor, and a sort of
and let's give you an idea of this working again.
Either, first of all, it's going to go through the LED, through the bridge rectifier in one direction and charge up the capacitor, and then when the power changes, it will discharge, and it will then push that current effectively back through the opposite direction and make the LED light up. That's a simplified description of what
That's not supposed to move.
I have plans to do a more complex video on electron theory, which will actually make you realise what electricity is, but that's definitely going to be a 2-beer video. That is going to have to involve lots of beer and whiskey and vodka and coffee and things like that. But will be a complete revelation when I actually get around to doing it, because it's quite a spectacularly complex video, but I'm going to try and make it as simple to understand as possible. Once you understand, it just makes things like capacitors, resistors, inductors, suddenly everything will make sense. Now I've said that, I really have to get around to doing it, which is probably a good thing. That's going to give me the incentive to do so.
There we go. Now we've bunged it out. Now we're in trouble.
So here's a 1K resistor going in to limit the inrush current, because as that capacitor charges up, it could be quite high pulse of current. The resistor, the 1K resistor, its function is to limit that to a maximum value. And if you consider that it's going to see potentially 240 volt across that 1K resistor, that would be about 1/4 of an amp, but it's only going to be a brief spike. So it's not going to see it on an ongoing basis.
Right, so my plan
risk of damage, or reduces the risk of damage.
might involve removing the LED again.
The main advantage of this circuit with the capacitor,
So I recently purchased, when I get in this old fishing tackle box, makes good component holders.
That you're going to get a much better LED. That is now at the level that I can point at a surface.
God, it's damn hot up here.
He said completely failing to illuminate the surface very well, because it is very bright now. So that just gives you one example.
Let's see if we can get one of these chrome bezels to fit.
If you wanted a modest intensity, how bright is that going to be? How bright is that? I can measure that. I've got 1K resistor.
It says dropping it. Right, I'm going to pause this while I just have a look at fit of this to the case. Okay, so with a bit of fettling, I'd have to take a slight bit of material out of here. The 5mm bezel will fit. As you can see, it's a bit out there at the moment. However, as far as the 3mm goes,
they'll just go to sleep after a while if they don't detect the load, and then you have to reset it, which is kind of pointless in this application. However, after I'd made that, I decided
that will hold in.
Make a few more, and I ordered up
If
some
I use that
modules. But I also thought, let's take a look at these little microwave modules, because they're
I was going to say it'll fall straight through.
And I was quite interested to
But
see
if I use
what their current consumption is.
two of those locking nuts, one on either side, that'll actually work.
With the standard passive infrared module,
These are, I tell you, when you've got hands the size of flipping JCB digger shovels, these are a pig to undo.
Their current consumption is measured in microamps. And I pondered, are these going to be able to draw low enough?
So that'll fall straight through as it is.
RF oscillator running all the time. You actually, pose such a low demand in the power that the battery, the charge will last a long time in standby. So I ordered some, and when I went to the transistor, it actually...
Okay, so I've had to wedge the circuit board in there. It's slightly too long with the chrome
I've often said that you're never going to be an expert
bezel in there.
Area of electronics, because there are so many special
as you can
sectors,
see,
and there are people who their whole life is spent working with microwave transmitters and technology.
That's working quite well. So that just flaps around a little bit. But all we're going to do is literally take the lid,
So there's the 3 decoupling capacitors, which makes sense. That they need to
And there we have it.
supply for
There's our on-off switch.
Then, with this
There's our little torch head.
here, from the positive, they couple that
And
to
now
this capacitor here, which is another
being
100
sterilised.
capacitor. And it provides a stable supply. It provides a stable base supply for the transistor. Then they use these
So yeah,
transistors here.
neat little project, bit of fun, and we've slightly modified it to our own means. So play with your electronics, buy this cheap shit, have fun with it. You never know, you might knock something decent up out of it. Please like the video, subscribe to the channel, check out my other videos, leave comments, let me know what you think, and I'll see you in the next video. Down the shed.